Welcome to this explainer. Today, we are uncovering the hidden mathematical architecture that literally powers the moving world around us. Have you ever just looked at the environment you interact with every single day and wondered what invisible rules govern how things move, grow, and change? Well, that's exactly what we are going to decode today.
Let's kick things off with a slightly weird question. What do thrilling, stomach-dropping roller coasters and the vapor trails of skywriting jets actually have in common? On the surface, absolutely nothing, right? One is this massive heavy metal track anchored to the ground, and the other is just ephemeral smoke up in the sky. But structurally, they share the exact same underlying logic. They are both perfectly governed by a specific kind of math that flawlessly tracks complex curves.
Here is our roadmap for today to master all this hidden math. We'll be looking at 1. The hidden architecture, 2. Defining the mathematical sentence, 3. Hidden in plain sight, 4. Math in your surroundings, and finally, 5. The bridge to your future. We're going to take you from the basic building blocks straight to your future career.
All right, let's jump right into Section 1, the hidden architecture, tracking a moving world. Because let's be real, our physical reality rarely moves in perfectly straight lines or stays exactly the same.
Think of this math like playing with building blocks. On one hand, we've got a fixed starting point. These are your unchanging baseline values. And on the other hand, we have changing variables, values that shift around based on how many items are added or how much space is filled. The true power here is in the combination. We're combining a fixed starting point with changing variables to see how different parts work together to create a final, unified result. It's kind of like calculating the total cost of a massive project or figuring out the volume inside a shipping container.
So, what do these blocks actually create when we snap them all together? That brings us to Section 2, defining the mathematical sentence, patterns and combinations.
Okay, so a polynomial. It sounds like a big, intimidating word, but it's really just a mathematical sentence. It tracks how a total value changes when we vary something like time, distance, or quantity. Instead of just staring at an isolated single number, we use this sentence to organize multiple, constantly shifting influences into one clear, predictable structure. It's literally the language that allows us to track expansions, contractions, and curves smoothly.
Let's put this into everyday terms. Think about total wealth. Your wealth equals your cash plus your property value plus your investments. Now think about it. Each of those elements grows at a completely different rate. Cash might be super stable, property value might climb slowly over years, and investments, well, they might fluctuate wildly day to day. But by stringing them all together into this mathematical sentence, all those complex shifting movements are broken down into simple, manageable pieces that just add up to your total wealth.
Moving right along to Section 3, hidden in plain sight, polynomials in day-to-day life. Let's look at how these mathematical sentences surround us everywhere.
You might think this kind of math is just permanently stuck in boring textbooks, right? Well, actually, scratch that. Think about your weekly shopping budget. You're calculating costs for varying quantities of fruits plus a fixed delivery fee. That's a polynomial. It's in the safe, smooth ascents of those roller coasters we talked about and those curved vapor trails left by jets. Polynomials even help landscapers calculate how much soil they need for complex, curvy lawn shapes, and they allow business owners to model exactly how their revenue will change if they tweak their prices.
And honestly, it goes way beyond that. Trying to predict exactly where a kicked football is going to land? Yep, that's a degree 2 quadratic polynomial. Distributing weight safely across massive bridge arches? Polynomials again. They even help your smartphone algorithms adjust your screen brightness smoothly when you walk into a dark room. On a macro level, governments use them to predict city population growth, and engineers use them to design banked highway curves so you can drive safely at high speeds. It's wild.
Okay, let's get into Section 4, math in your surroundings, translating life into math. Let's see how specific mathematical terms map perfectly to things you already do.
Let's translate some of this math jargon into real life. Think about cooking a festive meal. Each ingredient you use, like onions or spices, is a term, and the exact quantity, say 3 kilograms, is the coefficient. What about the degree of a polynomial? Well, just picture building floors. A simple one-story shop is like a linear equation, but a massive multi-story mall is a higher degree. Your constant term is that pesky monthly internet bill, a fixed base price you pay regardless of how many gigabytes you use. And the zeros? That's simply the exact split second a thrown ball hits the dirt. Height equals 0. Boom.
And the basic math operations? They translate beautifully too.
Addition is really just combining two family budgets for an awesome vacation. Multiplication is calculating how much carpet you need by multiplying the length and width of your room. And division, specifically finding the remainder, is exactly like distributing sweets to a classroom full of kids. The mathematical remainder is quite literally the leftover sweets that just couldn't be shared equally.
All right, time to raise the stakes a bit for our final stop. Section 5, the bridge to your future, the ultimate gateway.
There's this fantastic quote, "Polynomials form the grammar of calculus and physics." Just let that sink in for a second. You literally cannot write a novel without understanding basic grammar, right? Well, in the same way, describing the rapid acceleration of a rocket or the exact rate of a chemical reaction absolutely requires this mathematical language. It unlocks everything.
Being able to confidently manipulate these expressions, it's practically the cheat code for almost every high-level career in science and technology. Whether you want to be an ISRO aerospace engineer mapping out complex orbital trajectories, a data scientist writing predictive algorithms at a tech giant, or a financial analyst forecasting global markets, understanding this stuff is your absolute key to advanced problem solving.
But hey, before you land those dream jobs, you've got to pass the gatekeepers, right? For students aiming for the most prestigious institutions, polynomials are a super high-weightage gateway. They often directly decide your exam rank. In the IIT JEE, they are heavily featured in complex numbers and the theory of equations. For NEET, grasping the rate of change through these functions is totally vital for dominating physics and physical chemistry, and you'll see the exact same thing for BITSAT and IISER.
To really excel, though, you need what we call the industry bridge mindset. It means you aren't just memorizing formulas in a vacuum just to pass a test. When you train yourself to intuitively see the math happening in a sudden 20-degree temperature drop or the complex trajectory of a drone flight, finding the solution starts to feel completely natural because you already recognize the underlying mathematical sentence. So as we wrap up this explainer, I want you to really look around. The next time you're outside, check out the arc of a lawn sprinkler. Notice the changing volume bar on your phone, or feel the curve of the road you're driving on. Ask yourself, what invisible mathematical sentence is writing your reality right now?